Hi, my name is Ahaan. I go to Fremont High School, and I'm doing the ball tracking robot. And my modifications were a status LED and a real-time map of the robot's movements. So, a description of this modification is that I'm using these IR speed sensors on the bottom here, and next to the motor are these rotary wheels, which is like a little wheel with periodic holes in them. And so, what the sensor is that it's like two little poles which have a laser going between them. And as the rotary wheel spins in between the two poles, it'll break and reopen the IR sensor, like the laser in between the two poles. And so that is how it calculates how much the motor is moving. So then using that and converting the pulses in seconds into centimeters using an equation, I'm able to find the distance, which was displayed on my top screen here. And so I use that to display how far the robot has moved in centimeters from its starting point. And using both two sensors at the same time, one for each motor, I was able to uh, control a turtle, which is a drawing library in Python. And by controlling the turtle based on the motor's movements, I was able to effectively map the motor. So challenges I had was I had this idea and I originally wanted to use an MPU 6050, which is a motion processing unit, and the MPU was not accurate. Like you couldn't find the exact angle that I was going, and there was no way to detect linear movement. So I kept getting really bad errors, and just like the readings were really off. So I decided to switch to IR speed sensors because they were much more accurate and they were based on the actual movements of the robot. And for my next steps, I would I would like to refine it and make it so that the line is smoother and not like as rigid as it is now. And I also would like to make it so that the robot can stop every time it sees the ball and it's like super close to the ball. It can like stop.